Thank you. Wow, I have to admit that I have been very intimidated by talking in Scala days, but I can see many familiar faces here, so yeah, no pressure. Many of you already know me, so if I say something stupid, another day in the office, okay? So yeah, it's an honor for me to talk about a topic that has never been discussed before, like the monolith and microservices. But the reason and the motivation to keep talking about this is because even when there are like many millions of entries in Google or thousands of books in Amazon about microservices, I have the impression that not many of them are based on real world experience. Specifically, not many of them are based on high scalable and distributed systems that are processing millions of transactions. And this is what I meant to do in the next 40 minutes. I will try to, based on my experience, talk about how microservices are working in the real world, okay? So I would like to recap the principles about microservices, the architecture of microservices. Let's start with loosely coupled, that it means that at the end, the microservices are interconnected to each other through well-defined APIs, so code is not coupled anymore, or loosely coupled at least. And also the teams are independent to work on the microservices independently. They can make their own decisions, work more autonomously, and the same thing with deployment, in the sense that if you have the authority or the accountability to maintain a microservice, you can define the releasing cycle independently. This is good, and that's also impact in many different ways. In terms of single responsibility, that's also a principle very important, because you can decompose every business capability of your monolith, separated in small programs. Every program will take care only of these small business capabilities. In terms of scalability and resilience, the same thing. You can adjust how many instances of your microservices you want to have in production. The fault isolation, that's a principle that is very important as well, because even when microservice can fail, obviously, it's not going to bring down the whole system. So in paper, in theory, all the principles, it sounds very, very good. It brings with them many benefits. For example, the scalability, the elasticity, the responsiveness are like consequences of the principle of scalability and resilience. Because like I said before, if you need the instance you need more instances because you have like more demand for a period of time. That's something that microservices let you do without incurring in much cost. In terms of modularity as well, this is a benefit that is so important in development, because you can have like teams of developers working in parallel in the same feature, but in different layers. In terms of maintainability, also flexibility, because you can choose the tools you want to use for every specific microservice. Finally, in terms of evolvability, I don't know if that word exists, but for me it makes sense that small changes of the business logic affect to only certain parts of the code. That makes the possibility of going into production faster. Okay, so this is the theory. I think that nobody will disagree with me that this theory is beautiful, but I would like to tell you a story about the story of John. John Doe is a developer in 2014. This story, it has like many episodes. I think that many of you will identify with at least some episode. Okay, if so, please raise your hand. We can talk about this theme. It's not a happy ending story, by the way. So John, it's 2014. He's working for Acme Corporation. They are all the team working in a huge monolith, and they are struggling to fulfill the SLA expectation, for example. They have the feeling that the code is very coupled, and there is no possibility to scale. So John was reading a book about microservices. He and his team was falling in love with microservices, which is something that has happened to many of us, I'm sure. So by then, they started to discuss what is the perfect granularity of the microservices composition. Like, that's basically the first question you have to ask. What are the small business capabilities that I want to have separately? They find agreements. Suddenly, they have teams taking care of microservices autonomously. Okay. For now, we are respecting all the principles, and we are taking advantage of all the benefits. But yeah, of course, they are very used to submit data through HTTP protocol. They like how JSON serialization works. It's very understandable for humans, and they don't even consider the possibility to use different protocol, which is fine. For first time ever, they need to put in place in the operational layer the service discovery, not only in one environment, but in all the possible environments. So that starts causing more cost, more complexity, but that's fine, that's assumable. So very smart. John proposed to do a contract-driven development. That way, they can all start working in parallel with no interference. They are going to respect the contract. They are not going to write the contract by hand. They are going to start defining the APIs, Open API, another library like Swagger or something like that. We generate the contract for them. And for now, everything is everybody's super happy. They are very, very proud of the decision they made. But they started to realize that obviously every decision has like downside. And in this case, they start to realize that the microservices talk to each other. Every microservice is exposing an API, but some of the microservices are having more consumers than others. That means that all the consumers are implementing their own client, so that they are incurring in many code duplication. That is another factor that is very important when this happened, that is problematic, is that we are talking about a team that were working in a monolith, and now they are having a distributed system of microservices, and now these microservices need to talk to each other, and that means that if the first time they need to write proper encoders and decoders for all the models that will be through the wire, right? There are many tools to do codecs automatically, but we have here special cases where they are very good Scala developers, and they thought that they wanted to use refined types. in the sense that, for example, user ID is no longer a string or a UUID. It will be a refined type with certain rules, okay? And the semantic of top of those models cannot be expressed in Open API in 2014. So that means that not only the clients are duplicated, but also the encoders and decoders are duplicated. Not all the teams are using the same rules. So the user ID or the email or the last name could be a string or not-empty list, not empty string or whatever. So they have different semantic behind this. This is starting to cause many problems, but they are smart. They propose to, in order to avoid duplicated implementation, they propose to that every microservice will expose a wrapper of the client as a binary dependency. That way, nobody needs to implement a client anymore, and that is more convenient, and there is no duplication there. If one microservice considers that the user ID is a FUUID or something like that, it will remain like that, okay? But the problem with that is very, by the way, that sounds familiar to you, that's happened to you. Okay, I'm glad that I'm not the only one. I'm not young, by the way, okay? So that is a very common problem that's happening when you have multiple binary dependencies that you can incur circular dependencies. And that could cause problems, especially when you have versions of your library. Yeah. So how do they solve the problem? That's something that I have seen many times. Companies that decide to have a library called common, where they are putting the common clients or the common models, including the encoders and decoders. And that's fine. But the problem that everybody uses common for the common stuff. And the common stuff could be a type class that someone has created, super cool, or even some layers of the database access is in common as well, some business logic there, and suddenly common is where people put something that considered is interesting for everybody. Without realizing, we are converting our microservice system into a distributed monolith again. The code is super coupled. And yeah, they have a problem with that. But I want to talk about other episode that is unrelated to this somehow, is that if they were struggling to fulfill the expectation of the SLA when they were a monolith, trying to imagine how difficult it is to accomplish the latency when you have to make many nested requests through the network. It's impossible. They consider that maybe HTTP protocol and JSON wasn't the best option, and they were okay, they were right with that. So they started to discuss what's the next solution. Maybe gRPC is much efficient. Obviously, protocol buffer is. Are you familiar with this? Yeah. Yeah, that makes me very happy. I'm sorry. I was wondering if I'm going to talk about this, and I said, no, I've never seen that problem before. But yeah, that is a very common problem. They can actually have a hybrid. They can use Kafka with Avro for asynchronous communication, but they can keep having gRPC for streaming of data or something like that. So after fight and finding an agreement, they put in place this solution that is not easy, that requires a lot of effort and cost and time. Then they realized that the processes for QA and testing are very degraded because people people doesn't know how to test Kafka topics, for example. People that were used to use Postman for testing a request, they cannot do it anymore like that. They are facing new challenges. Not only this, but that is another problem that happened with microservices, that while everybody were working in the same monolith, it's like there are people that are more expert on database access, other more experts on middlewares, and that's fine. They can work together in a monolith. But when you have multiple teams responsible of microservices, like everybody needs to know everything and being an expert about every layer in the microservice. Like that is the principle, like you build this, you run this. That means that you need to be an expert on serializing, on dependency injection, or I don't know, even you have to know about DevOps engineering, because now you have to deal with Zookeeper or schema registry and stuff like that. So that is another thing that people don't tell you in the books. Yeah, trying to run this locally is a pain as well. Developers start to be unhappy about the new system, but they are doing microservices, so yeah. So the worst part that the monolith is still working. I mean, the people don't like to turn off the monolith just in case, and you have the cost of the bad things of the two worlds, okay? If we talk about joint queries, they are very expensive. I can continue to talk many episodes of this story, but I think that you have an idea already of what I want to say, is that in the real world, that is not that beauty. We are breaking some of the principles. We are not taking advantage of many of the benefits in terms of modularity or team working independently, or in the, yeah, as you can see, many of those principles have been broken. So I'm glad that some of you have been laughing, because it's not only the story of John, it's the story of many, many companies. I am mentioning here only 6 of them, but if you search, there are many of them that after the experience with microservices, they came back to the monolithic approach, okay? You can read a little bit of the reason of why those companies came back to the monolith, but I have here a summary. It's pretty common. It's the complexity and the coordination between the team to make sure that the communication across the microservices is something not trivial, and that provoke like overhead in the team. Also, the development and the deployment is much difficult. People need to start using tools that they didn't need to use before. Or in terms of operational challenges as well, because there is no way to debug a cluster of microservices if you don't have proper tooling, proper observability strategy, okay? In terms of productivity, it's the same thing. People need to be switching the context many times. As I said before, they need to be like expert in every layer of the development. And that's something that makes the engineer not very happy, okay? So what I have done is I have collected like 8 questions that this is what I will ask myself if I have to make the decision of choosing one architecture or the other, okay? So let's start with the requirements. That the first thing I will ask myself is about the requirements of the project in terms of performance, scalability, modularity, development speed, or the technology diversity. I will compare this with the principle of the microservices. If much, maybe I'm in the right path, okay? Another thing that's very important is to know your team. Obviously, they are going to implement this. If they don't have the background to do this, they are going to have pain. It's going to be difficult, so that is important. Even if you are planning to hire a team to implement this architecture, you have to make sure that they have experience with many aspects, like I said before, like in terms of tracing, logging, to being almost expert on communication protocols, because it's essential to know how they work. Also, in terms of time or resources, you have to take into account if you have the budget or the operational capabilities to have like a cluster of microservices running and being monitored all the time, and so on. In terms of flexibility, that's something very important to ask. If you expect that some business capabilities might grow faster than others, maybe that means that you need extra scalability. Maybe you can find like a hybrid solution where you have one monolith, and this part that you are anticipating that is going to grow can be one microservice, okay? At least you are going to incur delay or lower latency in just one single microservice, which is acceptable, but on the other hand, you have the scalability you need for this specific thing, okay? In terms of trade-off, that's also very important, because sometimes you think that you have to put something in the market very quickly, and you are willing to do some trade-off in the sense like, I will improve the metrics in the future. Okay, that's fine. I will improve the logging in the future. That's fine. But if you do this in the future, in the monolith will be something easy to do. In many microservices, it's going to take longer. So have this into account. Also, that's something very important, the technology, because people think that now that we are moving to a microservice, architecture of microservices, is the right moment to start using this beautiful library or this framework that is the best. Okay, nobody knows how to use the library. So you have a problem. Now you have like 10 teams learning how to use a framework. Working in parallel, learning in parallel, basically. If you have the same problem in a monolith, the problem is different. You can have some people implementing the first part of this framework. You don't need everybody to be learning the framework at the same time. The infrastructure requirement, as I said before, is like every team that are dealing with microservices need to have like DevOps in their team, because they need to know how to, in terms of infrastructure, how to run this everywhere. Finally, in terms of risk and complexity, that's also important. You cannot ignore the fact that the people will need to do proper testing or QA or debugging. That's something that is not, it's very important. If these questions don't bring you to take the right solution, decision, I'm going to talk about cost, okay? That is a little bit objective, okay, because that is not like a universal rule to determine that a monolith is cheaper or more expensive than exactly the same solution in microservices. That is not a rule for that. But if we start talking about infrastructure, I think that because of the distributed nature of the microservices, it's easy to understand that you are going to need like more core, more memory, and you are going to need also memory for the service discovery or orchestration of the container, and that costs money as well. So I put there, so that is something symbolic. I'm saying here that the microservices in general are more expensive than Monolith, but we will see later that there is a threshold under which Monolith is more expensive, because as soon as you put this to run, you are going to pay. But the Monolith, the microservice, you can adjust, you can turn some off, you can turn on the microservice when you really need it. So I'm assuming this thing as well. In terms of maintainability, it's the same thing. I think that monitoring and debugging require more effort if you have multiple small pieces of programs. That's why I consider that in terms of maintainability, the cost is higher for microservices. In QA is where I can see like more difference, okay? Like the amount of force that you have to put to test properly end-to-end microservices is huge compared to microservices, because you are removing the network problem from that thing. And not only the network problem, but also the serialization and deserialization. So there is where I see like more difference. In terms of deployment and observability, yeah, it's fair to think that deployment, if you have to put a change that is going to impact to many different microservices, it's not going to be that fast as you thought initially. In terms of observability, the same. If you ever had to trace a correlation idea across the board, you know that it's not that simple. You have to have many instances of Datadog or whatever you have. That's expensive as well. In terms of development, yeah, I think that the costs are very similar, but a little bit higher in the case of microservices. So having this into account, that's more or less how it looks. I think that it's fair, but I don't have actual real data to compare. And this is what I said before, that that is a threshold that system of microservices will be cheaper, but as you keep splitting your microservices, having like more granularity or more instances of them, the microservices will start being more expensive. Okay, I would like to start talking about the communication. That's, in my opinion, that's the most important factor for me to don't like microservices for all the cases. Okay, as you can see here, that is symbolic. This is not real data, but you can see that in the X, right? X, yeah. What you have is the number of requests. The second for a monolith will be the same, because internally they will have processes to get your response as soon as possible, but it's not going to incur on delays for the network. But in the case of microservices, as you keep having nested requests, this will be linearly increasing. So if I want you to have a takeaway, is this thing, that the protocol matters, okay? that is one of the aspects that impact more strongly on the efficiency of your microservice. I put the link here to the reference to see this article, but you can see that the JSON is like superhuman readable, but it could be very inefficient. HTTP, almost the same thing. So compared to gRPC, for example, in the bidirectional type with streaming, it's like 4 times more requests in 1 second. So there is not much to say. When we talk about asynchronous protocols, it's the same. Depending on the one that you choose for your specific case, will be other ones better than others. I remember in Scala days, long time ago, someone was giving a talk about the difference between Abro and protocol buffer, and it was super interesting because that is not a rule to decide Abro is better than protocol buffer or the opposite. It's depending on many factors, and 2 of the most important factors is the size of the messages and how often they are going to evolve. So keep that into account when you are making a decision of what serialization you are going to use, okay? So yeah, when I was writing this slide, I realized that this is Scala days. I'm not talking anything about Scala. So I wanted to find like a correlation between Scala development using functional programming and the microservice architecture. Yeah, you will agree with me that that because of some of the functional capabilities of the language, like immutability or pure functions, enhance or facilitate some of the principles of the microservice architecture, in the sense that you can implement small pieces of programs independently, like stateless, I thought that I changed this slide, sorry. Like stateless services, okay? So, yeah, I think that I'm running out of time. I have some advices for you, for the one who wants an advice. Basically, if after this, or reading aloud about microservices, you still want to build a system of microservices, my advices are give us a call, okay? We like to work on this. We are very good doing this. But if you don't want to call us, the next advices are if the latency is important, if you have to accomplish a strict SLA agreement, use the most efficient protocol, which is gRPC. If you want to decouple the code by using asynchronous communication, do it, because it's going to impact radically to the when you do event sourcing, the code gets less coupled. That's obvious. That is something that I have discovered recently. How important is find IDL that supports refined types. Why? Because if you define the contract of your API and you put some semantic on top of the models, and this is part of the IDL, or your consumers will be in the same page, basically. They don't need to have different interpretation of what is an email, or so that makes the life easier, okay? The contract testing is crucial as well, because you always want to preserve the compatibility between server and client, right? If you break the compatibility, you want to know this before you deliver new code, right? And this is the best way to do it. Don't skimp on observability, because it's what is going to give you the resiliency you need. If you are not willing to make this effort, it's going to fail, like the 6 companies that I mentioned before. Finally, for microservices, a retry policy. If you want to keep saying that this is fault tolerant and the fault isolation is still in place, you have to put retry policy with a circuit breaker on top of this. It's not going to be retrying forever, right? If you can put like a backup data source, like with the caching policy, that's smart as well. That way, the system is not going to return nothing. At least you have something that you can provide, even if it's a little bit old. Okay. If you decide to stick to Monolith, that's fine as well, and we can help you if you need some kind of scalability there. I have some. I wanted to dedicate more time to talk about this, but it wasn't possible. But SBT settings are more complex than we think. If you have a monolith, sometimes there are some teams that have problem with the number of SBT settings. Once you have many modules depending between them, so knowing how SBT works will help you to move part of your modules into binary libraries or something like that. There are many possibilities to improve the performance of this. Use DB replication, asynchronous message queues for scaling horizontally. And finally, some companies, when they move from the microservices to the monolith approach, they are not doing what they were doing initially 10 years ago. They took some takeaway from the experience with the microservices, and that is very smart. You can in your monolith, you can, for example, you can pay attention to the CI/CD, or you can move some part of your code as a binary libraries. You can have independent teams working on this exclusively. Yeah, that's all I had for today. Thank you.